This is balance forces practice number 2. In this problem, we have a 700 Newton Baby Yoda is grocery shopping and pushing the cart. The grocery cart weighs 100 newtons and the groceries weigh 200 newtons. Baby Yoda pushes with 100 newtons of force and the cart moves at a constant speed of 2 meters per second. Okay, so there's a lot of information here, and we will go ahead and just go through this problem, okay? So we have Baby Yoda, and Baby Yoda is pushing the cart, okay? And inside the cart, there are groceries. Okay, so there's that, and Baby Yoda and the cart are on the ground. And there must be some sort of friction between them because they are moving at a constant speed. All right, and then of course, everything goes with Earth. Okay, so now we're going to go ahead and draw our force diagrams with Baby Yoda. So we have Baby Yoda is having an interaction with the Earth. Okay, so Baby Yoda and Earth. And the problem here says that Baby Yoda is 700 newtons. So Baby Yoda is 700 newtons. And we also know that the ground is pushing up on Baby Yoda. So we have normal force on Baby Yoda with the ground, and that is also happening at 700 newtons. Okay. And the reason why I know this is because I know that my forces are balanced. Right, so however much it is down here is going to be the same as up here. And the reason why I know that it is balanced is because it said right here that there is a constant speed of 2 meters per second, which means that constant means that there's balance force, right? All right, so now we have Baby Yoda pushing the cart to the right. Okay, so this is Baby Yoda pushing the cart, and the cart is pushing back on Baby Yoda. So that means that the normal force from the cart is going to the left. Okay, that's from the cart. And Baby Yoda is pushing the cart with, let's see, 100 newtons of force. So we have 100 newtons of force. That means our force of friction going the other direction on Baby Yoda from the ground is also going to be 100 newtons. Okay, now here the forces are also balanced, and we have the cart. We have a force of gravity on Baby Yoda with the Earth at, oops, sorry, this is no longer Baby Yoda. So now we're talking about the cart. And the Earth. So just the cart is 200 newtons, right? Oh, sorry. No, it's 100 newtons. Okay, so this is 100 newtons. And let's see what else. So we're taking a look at the cart, and we see that there is a force with the ground, a normal force with Baby Yoda, a normal force from the groceries, and a friction force, and the Earth. Okay, and so we see that the groceries is also pushing the cart down. So there's a force that's normal on the cart from the groceries, and that is 200 newtons because the groceries are sitting in the cart with 200 newtons of force. So that means that the ground is pushing up on the cart with the groceries inside it. So now I have groceries and ground. So I'm going to go ahead and change this to floor so that it'll be a different letter from groceries. Okay, so then let me change all of the stuff that I had previously labeled as ground to floor. Okay. Now, I don't recommend you change it while you're working on the problem, but if you see that happening, you should definitely change it. All right, so floor, and that'll be 100 newtons plus the 200 newtons. So this normal force is going to be 300 newtons. All right, now Baby Yoda is pushing the cart to the right. Okay, so the cart is feeling a normal force from Baby Yoda at 100 newtons. And so then that means that the force of friction that the cart is feeling will be happening in the other direction at also 100 newtons. Now, our third law pair here is going to be the objects that have the same force, right? So same type of force and happening in opposite directions. So this would be our third law pair. All right, so then that would be for the page 1 of our problem. Now page 2, we can go ahead and assume that we started at 0 and we're going after 5 seconds. So 1, 2, 3, 4, and then maybe 5. So at time 0, we can say that our position was at 0. Okay. Now, our problem here says it's a constant speed of 2 meters per second. So that means everything here, our velocity, okay, is going to be at 2 meters per second. So it's a constant speed. That means our speed isn't changing, and it's all happening at 2 meters per second. So then what that means is that every 2 seconds, or every 1 second, okay, our Baby Yoda and cart will be moving 2 meters. So starting off at 0, so after 1 second, we'll add on 2 meters. And then after another second will be another 2 meters. Okay, and so then they'll have moved another 2 meters, which is 6, another 2, which would be 8, and then another 2, which would be 10. And so the cart's displacement after 5 seconds, so we have displacement is equal to final position minus initial position. Our displacement is going to be 10 meters minus 0 meters, which will be 10 meters. Okay, and so we'll do 1, 2, 3, 4, 5, and 6. And then this one I'll go up by 2. All right, and so we have starting at 2 meters, right? Or sorry, 0 meters. And then after 1 second is 2. After 2 seconds, we're at 4, 6, 8, and 10. And so then that will take us to our slope here. And so this shows us that we are increasing our position, but we are keeping the same speed. All right, so then here our speed would be at 2 meters per second. So 1, 2, 3, 4, 5, 6. So then here we just stay at 2 meters per second for 5 seconds. Okay. And so the cart will still be moving at 2 meters per second after 5 seconds, because we don't know if they stopped or if they slowed down or if they kept going. So we'll just say that they're still moving at a constant speed. That's it.